Hello, abstract algebra students. We now finish the proof that P of M is closed under symmetric difference. So in the last video, we had set up the structure of the proof, but we just did not do the element chase and clean. So remember, we were trying to show that asymmetric difference B is a subset of M, which means we needed to show for every X, if X is a member of asymmetric difference B, then X is a member of M. And that's what we will do now. So our element chasing claim is a quantified if-then statement. So we should begin by letting X be given and assuming that X is a member of asymmetric difference B. So let X be given, assume X is a member of asymmetric difference B. Now, let's unpack our assumption. Remember, if X is a member of asymmetric difference B, the symmetric difference means everything that is in one but not the other of the sets. So it means that either X is in A but not B, or X is in B but not A. So since we know that X is a member of asymmetric difference B, by definition of symmetric difference, it follows that either both X is a member of A but not B, X is a member of A, and X is not a member of B, or both X is not a member of A, and X is a member of B. If X is in one but not the other of the sets A and B, it means either both X is in A and not in B, or X is not in A and X is in B. Now remember, in proof writing, anytime we know either one thing or another, we can split into cases. So consider the following cases. And our two cases are going to be, we assume the first thing. So we assume both X is in A and X is not in B. That's the first case. And then the second case is we assume the or. So we assume both X is not in A and X is in B. Now, our goal in each of these two cases is to argue the then part, that X is a member of M. So in this first case, it looks like we know that X is a member of A and A is a subset of M. That's enough to get X in M. Therefore, since we know that both X is a member of A and A is a subset of M, by definition of subset, we may conclude that X is a member of M. And a hollow square there, because that ends this part of the proof. Now, let's do the same thing for the second case. Here, again, we want to get the x as a member of M. So we look at what we know. We know that x is a member of B. We know that B is a subset of M. So, therefore, since we know that both x is a member of B and B is a subset of M, by definition of subset, we may conclude that x is a member of M. Again, we'll put a hollow square there. Okay, so you see in either of these two cases, we have argued that x is a member of M. So now let's just end the cases by saying, therefore, having proven x is a member of M in both cases, we may conclude that x is a member of M. Now, I believe that finishes the element chasing proof, because we let x be given, we assumed that x was a member of asymmetric difference B, we assumed the if part, and we have concluded the then part that x is a member of M. So with the element chasing proof done, we now have a complete proof that the power set is closed under symmetric difference. That is the final proof for this lecture. And in the next screencast, I will wrap up what we have done in this lecture. Stay tuned.